Okay, in this video we're going to talk about electronegativity. Electronegativity is the ability of an atom to attract a shared electron towards itself. Okay, so we're talking about bonded electrons. We don't know tons about those yet. You will know in a month or two, but you can still understand this trend. So I'd like to tell you about a situation in my life, okay? So my son, he's 2 years old, he goes to daycare, okay? And he has a hard time sharing with other kids sometimes because he's an only child, okay? So a lot of the times toddlers are going to fight over toys. And so here's a picture of my son fighting over a toy with this other girl that's in his class, okay? So you might sit here thinking, which toddler is going to be able to pull that toy towards themselves more? Okay? You would have to know the relative strengths of the children. So let's say my son is really muscular, a 2-year-old with muscles, okay? He's going to be able to pull those electrons towards himself or pull that toy towards himself because he has a stronger hold on the toy. Okay? So I want you to think about atoms like toddlers fighting over a toy. Okay, but that toy is an electron. Okay, so when we're thinking about electronegativity, we're thinking about, hey, who's going to be able to pull an electron towards itself more easily? So let's talk about it in terms of the periodic table. So as we go left to right on the periodic table, electronegativity increases, and as we go bottom to top, electronegativity increases. So if we look at lithium versus sodium, you might assume that lithium has a higher electronegativity, and you are right about that. Okay, but the key here is that you need to understand why. Why is this trend happening? So we know that lithium and sodium are in the same family, but they do have electrons located in different energy levels. So if you draw a quick Bohr model of lithium, you would find out that lithium has electrons in 2 energy levels, whereas sodium has valence electrons in 3 energy levels. Give me just a second to draw all these electrons. So when we're going top to bottom on the periodic table, we're comparing 2 different elements in the same family. You're going to be focusing on energy levels. So let's think about attraction. Which nucleus has a stronger hold or a stronger attraction to its outermost electron? Okay? And again, we're thinking about this in terms of a bond. Technically, we're thinking about like 2 electrons, 2 atoms sharing this electron, 2 atoms sharing this electron. Okay? But the point is lithium going to be closer or is sodium going to be closer? Okay? We know that lithium has a shorter distance between that valence electron and its nucleus, so it's going to have a stronger attraction to the electrons and be able to pull the electrons towards itself. I'm going to write you guys an appropriate test response so you can kind of start studying, okay? So, from top to bottom of the periodic table, the number of energy levels, or those shells of electrons, increases. Okay? This means that the nucleus is farther away from the electrons in the bond. So it will have less attraction pulling electrons in. All right. So sodium is going to have a smaller electronegativity than lithium because its positively charged nucleus is farther away from those shared electrons, and so it doesn't have as much of an influence to be able to attract those electrons towards itself. Last one here, we're going to look at lithium versus beryllium. So if you know the rules, you know that beryllium has a stronger electronegativity than lithium. So because we're in the same period, we're going to look at protons. Lithium has 3 protons, whereas beryllium has 4 protons. So this charge, this number of protons, is giving us a hint to think about attraction, kind of like magnets, okay? So from left to right, the number of protons increases. This increases the nucleus's